All right, welcome to Chapter 8. This chapter covers quite a bit of information, so we're going to jump in pretty quickly and get started. One thing I like to tell everyone at this point in the class is, we're at the end of the class, and if you noticed as we went through the class, you almost got to be a part of several different roles that you might find in the database, the data kind of career path. The first was kind of that design development piece. Oftentimes, that's more of a data architect kind of person. Then we got into administrating the database. And so that is much more on the DBA portion. And then finally, we have this area, which is more of the database programmer side of things. And a lot of these positions, they can be all one position. They may be split into several different positions, but they are definitely different kind of fields in this database career. So let's jump in, and like I said, we're talking a little bit more. This is going to be definitely a lot more about programming databases. So we're going to jump in, and we're going to talk a lot about some functions that you can use in database programming. We're going to talk about some very specific ones like upper and lower, round and floor. We're going to talk about how to manipulate some dates within SQL. We're going to talk about putting together queries that you can then use in either PL SQL, which is for Oracle, and T SQL, which is Microsoft SQL. We're going to talk about using single rows to embed single data. We're going to talk about updating tables using embedded insert, update, and delete commands, all within our P-SQL or T-SQL. We are going to talk about cursors. Cursors are a really important piece when you're talking about making use of store procedures and things of that nature. So we'll definitely talk about that. We're going to talk about how to manage errors when we're building our store procedures, as well as using SQL and SQL commands, because there are commands that are embedded that we can make use of in SQL. We're also going to talk about triggers. Triggers are just a very specific form of coding, but we'll dive into that as part of this chapter. So let's go ahead and get into it. So using SQL in a programming environment. The thing to understand is SQL is a non-procedural language. It uses simple commands to communicate tasks to computers. Now, you that have done some programming classes, you'll notice that the difference between SQL and versus a programming language is SQL is pretty simple. It's pretty generic. There's not a whole lot of complexity to the language. It's meant to be simple and straightforward. So when we talk about PL SQL, it's a procedural language. And you're going to provide step-by-step processes to accomplish tasks. So in other words, we're going to put a lot of SQL commands together along with SQL queries to produce a piece of code that can accomplish multiple tasks, or accomplish one task that just happens to be a little bit more on the maybe a little bit more complex side. So we can use embedded SQL in other languages such as PL SQL or T SQL. Again, that's the big difference. I think we might talk about it a little bit more here in the future, but PL SQL is what you do. It's the common language inside of Oracle, while T SQL is for SQL Server. Using SQL in programming environments. It's useful when you need tasks that are beyond just the capabilities of SQL. And what they're saying here is, we've been doing queries throughout the semester, and that's great, but you might need to do more than that. You might need to do a query, do some data manipulation, and then save that data back. To do that, to design a query to do something like that, very complicated, and oftentimes that's where you want to get involved with making use of like PL SQL or T SQL. So let's talk about functions. Functions are pieces of programming that exist for you to make use of. In fact, at some point, if you get really good at your SQL, you can even create functions. But here are some of the functions that are kind of built into to SQL that we can make use of. So the aggregate functions. These perform calculations based on groups of records. Sum is an example of an aggregate function. There are definitely other examples of aggregate functions. You can, I believe, somewhere in the book, as well as you can do a Google search and come up with some different aggregate functions. But that's what those are. Sum's a great example. Other SQL functions, and these affect single rows. They vary from one single SQL implementation to another. So we'll talk about some of those. And this is the upper function. So the upper displays a value in uppercase letters, and then the same thing with the lower, except it does in lower cases. One of the things that we talked about earlier in the semester is when you're doing your where clauses, if you use the equal sign, you have to have the right case. One way to get around that is go ahead and modify the case as it's being returned so you can look at it. So you could use, and you could say, hey, where my this particular column is this, and wrap that in the upper, and make sure you display, you're looking at a value that equals all the upper letters of that thing. So I think paddling was one of the ones that we said type equals single quote, and we had to put paddling, and we had to capitalize the P and lowercase everything else. Well, if we put upper around the type, we could then say equals paddling all in uppercase, so we don't have to worry about making sure we match the case perfectly. So you can use this in the where clause, and you can access uses of U case and L case. So let's see if we can have a little bit of an example here. So we're saying select rep number, and this time we're saying upper L name. So what's going to happen is it's going to return all of the this particular column, the last name, in uppercase. All right. So some other functions, and this is more around the numbers. So we have round, which you can use to round values to a specified number of decimal places, and it requires 2 arguments. And then floor truncates everything to the right of the decimal place, which is not supported by Access. So let me take a moment to explain. Rounding does rounding just as if you learned it back in probably elementary school, right? So if it's dot, if it's 5 or up, it's going to round up. If it's less than 5, it rounds down. Floor literally truncates the decimal place off. So there's no rounding. It doesn't matter if it's 7 or 8 or 2. It just truncates it off. There's no rounding whatsoever. So in this case, we're saying select item number, round. The column is price. And we're telling it to use 0, which means don't allow any decimals as rounded price. So we're naming that column from item. Here's the example. And as you can see, there is no rounding. If you were to look at the number, the decimal point, if it was 0.5, it rounded it up, so forth and so on. Now let's talk about working with some dates. This is pretty common. We tend to work with dates a lot in the database, especially if you want to create queries that are doing reports, hey, give me the last 30 days, that kind of thing. So working with dates is pretty important. We can add months, and that obviously adds a specific number of months to a date, has 2 arguments, and Access and SQL Server use date add. So kind of keep that in mind. When it comes to Oracle, we're going to use add months. Access and SQL use date add function to add months. And it adds a specific number of days. You can use a simple calculation, and you can also subtract. So working with dates. Sysdate, this obtains today's date in Oracle. The date function obtains today's date in Access. And getDate obtains today's date in SQL Server. I know this is an Oracle class, but again, this book was able to go over pretty much all of Oracle Access and SQL Server because they're so similar. And so that's why we do sometimes address those different values. So in here, we're working with Oracle. We're saying select order number. We're going to add months to the order date column, and we're adding 2 months to them as future date from order. So here we have the future date, which is the original order date plus 2 months. Now we're going to add some days. Now adding days in Oracle is pretty simple. We're going to say select order, and then the column name is order date, and we're saying +7. So this goes back to that add a specific number. So if you use the simple calculation of add, you're adding days. So order day +7 means it's going to take the date and go 7 days. Now, as you can see, 12/12 is 2 months ahead. So if we're just adding 7 dates, 10/19 is exactly what that number would be. And that's the future date. So now we've added 7 dates to the future date from orders. Again, just as we did with the plus, we can do with minus. So we're saying here, select order number, sys date as today's date. So this is going to be today's date. Order date, we're going to round sys date minus order date by 2 as days passed. So what this is doing is it's saying, hey, take today's day minus the number order days and tell us how many days past we are. And because this is going to not be a whole number, we're rounding it to 2 decimal places and naming it as days past from order. Why is it not going to be a whole number? Because remember, sys date and order date are also capturing the time. And so time is actually being compared as well. So that's why we don't have a full date. So order number, today's date, which by the way, this is not very common to see. You're not going to put something so typical that this is going to be the same number all throughout the entire record. So why would you do that? Most of the time people don't. In this case, it might be just enough to just remind people. Who knows why they're doing it, but this is not very typical. Order date and then the round. So here's that order date, and this is the days past. We can concatenate columns as well. So we can combine 2 or more columns into a single expression. And to do that, we're going to take 2 vertical lines. If we're in Access, it's the and sign, and SQL Server does the plus sign. rtrim, this is a great function. This is one that we use a lot. And that is because data, depending on where that data came from, might have spaces that are extra spaces on the end of the data. One example is if you import data, let's say from a flat file, and the flat file uses fixed length as the way it stores the data, there's going to be a bunch of spaces out to the right side. So this rtrim function is a great way to get rid of those extra spaces. Otherwise, if you're doing something, if you're trying to do a search using the where and you're using the equal, you would have to include all those spaces. If you didn't, you wouldn't find a match. So rtrim is a great function. So select rep number, right trim or rtrim, the first name. Because we're in Oracle, we're going to put the 2 pipes, and then we're going to add a space by putting single quote, space, single quote. Then we're going to concatenate again. Now this is, by the way, not an actual column. We are hard coding that space in. We used a column name and first name, and we're going to use a column name and last name with that right trim again as rep name from rep. So we're putting the rep name together is what we're doing here. And we did it pretty successful. If we didn't use the right trim function here, if let's say Megan had 3 spaces out the end of her name because of whatever reason, maybe when it was entered into the database, someone put 3 spaces at the end, then you would have Megan, 3 spaces plus that 4th space now, and then the last name. So again, that's why the right trim function is so helpful. All right, so I'm going to stop the video here. And what we're going to do is in the next video, we're going to talk about stored procedures. And we're going to take and make use of all the things we just spoke about And we're going to put it all together and we're going to start doing some programming and we're going to create some stored procedures. So I'll see you on the next video.